In this video, I am going to solve the problem 25th from chapter 26. Wire C and wire D are made from different materials and have length LC, which is equal to LD, which is equal to 1 meter. The resistivity and the radius of the wire C are 2 multiply 10 power minus 6 ohm meter and 1 millimeter, and those of wire D are 1 multiply 10 power minus 6 ohm meter and 0.5 millimeter. The wires are joined as shown in the figure, and a current of 2 ampere is set up in them. What is the electric potential between the point 1 and 2? And the second question is, what is the electric potential between point 2 and 3? And the third question is, what is the rate at which the energy is dissipated between the point 1 and 2? And the fourth question is, what is the rate at which the energy is dissipated from point 2 and 3? So here we have to answer these four questions. So first of all, we have to know what is given in the question. So here in this figure, you have to see there are two wires, the wire C and wire D. Both C and D are in the same length. So the length they mention here as 1 meter. And the resistivity of the wire C is given as 2 multiply 10 power minus 6 ohm meter, and its radius is given as 1 millimeter. Likewise, the wire D resistivity and the radius are given here, and the current in this wire is 2 ampere. By using this, what we are going to do, first of all, we are going to find what is the potential difference between the point 1 and 2. That means in this distance, what is the potential difference we are going to find in the first question. Likewise, we are going to find the potential difference between the point 2 and 3. Likewise, in the third question, we are going to find the power calculation between the point 1 and 2. And likewise, we are going to calculate the power between the point 2 and 3. So these are the four questions we are going to find the answer. First of all, I'm going to write the given first. So what is given here? The length of wire C, which is equal to the length of wire D, which is equal to 1 meter. The resistivity of the wire C here given as 2 multiply 10 power minus 6 ohm meter, and the radius of the wire C here given as 1 millimeter. If you convert this millimeter in terms of meter, 1 multiply 10 power minus 3 meter. Likewise, the resistivity of the wire D, because both wires are different materials, that's the reason the resistivity of the wire C and D are different. So the resistivity of the wire D here they mention as 1 multiply 10 power minus 6 ohm meter. Likewise, the radius of the wire D here they mention as 0.5 millimeter. So if you want to convert this 0.5 millimeter to meter, we have to multiply this number with 10 power minus 3. So therefore 0.5 multiply 10 power minus 3 meter. Now in these questions we are going to find the potential difference. So what is the potential difference? How we can find? We can easily use the formula V, which is equal to IR. This is the basic equation. We are going to find the answer for the first two questions. Now you have to see here the potential we are going to find. So current already mentioned. So in both wire the current is set up as, let's see what is the current. The current value here they mention as 2 ampere, right? 2 ampere. So here, if you want to find the answer by using this equation, we need the resistance. So the resistance information is not given, but the resistivity and the radius value is given, as we already studied the equation for finding the resistance in the theory, R, which is equal to rho L over area. So rho is the resistivity, L is the length of the material, and A is the cross-sectional area of the material. So what I'm going to do, I'm going to first find the resistivity, so resistance value, by using this equation for both wire C and wire D, and after that I'm going to substitute that resistance value here for finding the answer for the first two questions. So let's start with the first question. So before that, what I'm going to do, I'm going to calculate the area, the cross-sectional area for wire C as well as the cross-sectional area for wire C. So how we can find? If you see the cross-sectional area of the wire, we just go back to the figure. You can see the cross-sectional area of the figure. It looks like an area of the circle, right? So we know the area of the circle formula as pi r square. So I'm going to use that formula for finding the cross-sectional area of the wire C. So therefore, area of the wire C, which is equal to pi RC square. So pi value is 3.14 multiply with 1 multiply 10 power minus 3 the whole square. So by that we will get the answer for the area of the wire C as 3.14 multiply 10 power minus 6 meter square. Likewise, I'm going to find the area of the wire D by using the radius of the wire D. So therefore, area of the wire D, which is equal to pi RD square. So pi value is 3.14, but the radius of the D wire is 0.5 millimeter. So I have to use the value of the radius in terms of meter. Therefore, 0.5 multiply 10 power minus 3 the whole square. So now we got the answer for the area of the wire D as 7.85 multiply 10 power minus 7 meter square. So now our work will be very easy, because by using this area we can easily find the resistance. After that, by using this equation we can find the potential difference between point 1 and 2 and 2 and 3. So now what I'm going to do, I'm going to find the answer for the first question. So for finding answer for the first question, first of all, I'm going to calculate the resistance. Therefore, the resistance of the wire C, which is equal to the resistivity of the wire C multiplied by the length of the wire C divided by the cross-sectional area of the wire C. So resistivity value and the length value already given. So the resistivity of the wire C, they mention as 2 multiply 10 power minus 6 multiply the length of the wire C is 1 meter over the area, the cross-sectional area of the wire C. Just before we found the answer as 3.14 multiply 10 power minus 6. Here I got the answer for this resistance of the wire C as 0.6370. Now we are going to find the answer for this question, because we are going to find the potential difference between the point 1 and 2. So therefore, V of 1 and 2, that means the potential difference between the point 1 and 2. Which point? Let's just go back to the figure. You have to see here the potential between the point 1 and 2 we are going to find now by using the resistance value. So as we know the rule for finding the potential difference, V, which is equal to the current multiplied by the resistance of the wire C. So the current value already given in the question as 2 ampere. So therefore 2 multiply with 0.637. Now we got the answer for the potential difference between the point 1 and 2 as 1.27 volts. So this is the answer for the first question. Likewise, I am going to do the same method for finding the answer for the second question by using the information about the wire D. So first of all, I'm going to use the resistance. I'm going to find the resistance of the wire D. Therefore, R of D, which is equal to resistivity of the wire D multiplied by length of the wire D divided by the cross-section area of the wire D. Both the resistivity and the length information is already given, and we already found the answer for the area of the cross-section of the wire D. By using this, we can easily find the answer for the resistance of the wire D. So now I'm going to substitute the value here. So the resistivity of the wire D is 1 multiply 10 power minus 6 ohm meter multiply the length of the wire D is 1 meter over the cross-section value just before we found as 7.85 multiply 10 power minus 7. So here I got the answer for the resistance of the wire D as R of D, which is equal to 1.27 ohm. So this is the answer for the resistance. Clear? Now by using the resistance of the wire D, we are going to find the answer for the potential difference. So therefore, the potential difference between the point 2 and 3, which is equal to the current multiplied by the resistance of the wire D. So the current here they mention as 2 ampere. So 2 multiply with 1.27, we got the answer here as 2.54 volt. So this is the answer for the second question. So in the first part and the second part, we found the potential difference between the point 1 and 2 and 2 and 3. Now, for getting the answer for the question third and the fourth, let's we go back to the question. You can see the third question and the fourth question. We are going to find the rate at which the energy is dissipated. What it means? It exactly says about the power calculation. So for that, we are going to use the formula for power. What is the formula for the power? We have three formulas for the power. What are they? Power P, which is equal to current multiplied by potential. Also, we have the formula P, which is equal to current square multiplied by resistance. And we are going to use, and also we have one more formula, power, which is equal to the potential square, potential difference square over the resistance. So here I'm going to use this rule. I'm going to use this rule. Understand? So for getting the answer here, I'm going to use this formula P, which is equal to I square multiplied by the resistance of the wire C. So current already they mentioned in the question as 2 ampere. So therefore 2 square multiply with the resistance of the wire we already calculated as 0.637. I'm going to use that value 0.637 and we got the answer for the power between the point 1 and 2 as 2.55 watts. The unit for the power is watts. So this is the answer for the third questions. Likewise, I'm going to use the same rule for finding the answer for the fourth question. So therefore P, which is equal to I square multiplied by the resistance of the wire D. So current value already we have in the question, which is 2 ampere, and the resistance of the wire D is 1.27. So 2 square multiplied by 1.27, we got the answer for the power between the point 2 and 3 as 5.08 watt. So this is the answer for the question 3, C and D. Understand? That's it. Thank you.